Hello everyone, and happy Friday once again. Like I told you earlier today, I went back out to the exact same place I was 2 weeks ago, and we're going to test the water quality all over again. Like I also said today, if you are truly trying to test change in water quality, one of the things you have to do in the scientific method is repeat yourself over and over and over again. So if this was a real study, we would be wanting to do this probably anywhere from like 50 to 100 times to actually see real change. But just for the purpose of this lesson, we're gonna just test it twice to see what changes we have. As you know, a lot of people haven't been out, there hasn't been as many boats out, and in Key West there hasn't been any tourists as well. So we're gonna see if the water might be a little bit different, maybe a little bit healthier. So the first thing we're gonna do is use our refractometer. Now if you remember from today's lesson, this tests salinity, and that just means how salty the water is. Another thing we talked about today is how salinity is measured. So we use PPT, parts per thousand, and that's the type of unit we use to measure. And if it's a healthy ocean, we want it to be around 33 PPT, or parts per thousand. So with the refractometer, I took a sample of the ocean water right here. We're gonna fill this up just a little bit, and we're gonna place it right on this little glass area right here. You just need a few drops. You push the flap over and you look up into the sunlight to see. So it's actually a little bit different from 2 weeks ago. Now I know you guys can't see what's inside here, but like I said today, there is a scale and it goes in 5, so 5, 10, 15, 20, 25, and so on and so forth. And we want to see where our measurement hits that scale. If it says 33, that's pretty healthy. Today, it's a little bit lower. It's actually at 30 parts per thousand, or PPT. And that still is pretty good, pretty healthy. As long as it's close to 33, we have somewhat of a healthy ocean. All right, so next up, we are going to be testing pH. So this guy you can actually get at any like water testing store, pool store, aquarium store, anything of that sort, because it's what people use in their daily lives to test the pH of their pool, to test the pH of different aquariums. So it's a really cheap thing you can get, and so if you're ever bored and you want to see what the ocean or the lake or the pond is by your house, you can definitely get these. They're very accessible and, like I said, very cheap. So all you do is you take one of these little testing strips, we're going to dunk it into our test sample, and we're going to see which color it lines up with on our pH scale. Again, from earlier today, if you do remember, the colors that are like 1, 2, 3, that is on our pH scale of, and is very acidic. So acid, so think lemons and vinegar and battery acid, all those things that would make your skin burn or it seems like it would hurt your body, also would hurt our coral reef. Another thing we talked about today is that a healthy ocean is about 8.1 on the pH scale, and anything higher or lower means that our ocean is out of equilibrium or out of whack for many different reasons. Maybe the ocean's really polluted. Maybe the ocean has too much carbon dioxide in it. Maybe it's way too salty or way too hot. So pH is a great indicator of how our ecosystem is doing. So what we're gonna do, just stick your tab into your sample. You're gonna lay it out on our color scale. Hopefully you guys are able to see that. And as you can see, it's changing color to determine which the pH is. And I think actually it's about like a dark green color, which is right where that 8 is. So hopefully you guys can see that. But yeah, it's a little bit darker, so that's really good. That means that our ocean probably has a really good pH. So we are going to check DO, or dissolved oxygen, as well. We need oxygen to breathe, and so do fish and all other marine animals. This is another great indicator of how healthy our ocean is, because if there's no oxygen, then our fish and our mammals and our animals altogether are not going to be able to breathe. If there's way too much oxygen, it's going to throw their bodies out of balance. So once again, just the common theme between all these different things that we're testing, you need to find balance and equilibrium. So for dissolved oxygen, this one's the most complicated out of all of them. It's a kind of long process of how to test it, so I'm going to speed the video up a little bit and try and explain it as best as I can. But when we are testing for dissolved oxygen, we're using that unit of measure again. This one is parts per million. So let's review a little bit. If you had 1 million jugs of water, and you had 8 jugs of oxygen. If you put all of that into one big barrel together, that would be 8 parts per million. That's the number we're hopefully trying to get today. So eight. And that's like perfectly crystal clear. All right, so that's actually awesome. That means that there is a perfect amount of oxygen in the water. Like I said, 7 or 8 is like kind of the perfect number, and it is what we see a lot down here. So that is all I have for you guys today. Thanks for joining in. You can fill out those charts that we did earlier today so you can compare and contrast more of the water quality I tested 2 weeks ago and the water quality I tested today. But overall, the water quality today was really, really good. So that's awesome, and hopefully we'll get more water quality stuff in a few months, and we can do this again and again and again to be able to figure out what's going on with our water. So thanks, guys.